Now instead of seeing 4 or 5 beer makers that need to treat their waste, you're seeing 100. And a lot of these facilities are smaller than those initial large facilities, but they're getting to be large enough that they merit consideration from an engineering and technology standpoint. Typically, pretreatment systems at breweries didn't remove all the solids. So really, you'd end up just sending that water straight to a sewer. The tank only stores 2 days worth of flow. The solids are only in there for 2 days too. So they really are only able to convert the carbon that's easily digestible, the mac and cheese, just some quick, fast carbs. It's about 75 to 80% of the carbon in the feed source. If you're trying to get to the 98 to 99% of that carbon removed into methane, you're going to need some new technology. Using a membrane gets you closer to 30 to 50 days of time for the bugs to break down the food source. They're going to be able to get the proteins, the steak in your wastewater. Traditionally, what people have done to get to these high levels of COD or carbon removal is enormous tanks. And some clients just don't have space for that size of tank. So the anaerobic MBR technology really allows you to have a small footprint and still get some of the benefits of these really large digester sizes. A primary benefit of anaerobic digestion is that the production of methane is actually a recovered resource that you can turn into a natural gas product or biogas. I feel like the R&D program has really helped establish relationships with vendors and with clients where everybody feels like they're collaboratively researching a problem. We went on a tour of some breweries and found that there was some interest and desire to testing out the technology, and sometimes you realize you're really at the bleeding edge of this and you're testing something that they haven't possibly tested, and we did in this instance push these membranes quite a bit further, and they exceeded expectations of even the makers of the technology.